All right, today we're looking at rational functions and graphing them, and before we can graph them, we need to look at some of the basic characteristics of them. So remember that rational functions are just quotients of polynomials, two polynomials divided. And remember that the denominator cannot be zero. So that helps us when we're looking at domain, also helps us when we're looking at certain asymptotes. So looking at these two basic ones, 1 over x, that's your parent function. If we think about its domain, x cannot be 0. So we can go from negative infinity all the way up to 0, union with 0 to infinity. Now the range, just looking at our picture, also cannot be 0. So negative infinity to 0, union with 0 to infinity. Vertical asymptote. We can see that we have one right here. That's when y equals 0, or x equals 0. We also have a horizontal one right here, where y equals 0. And then just looking at the behavior of this, as x approaches 0 from the left, our f of x goes to negative infinity. Our function goes to negative infinity. And as x approaches 0 from the right, our f of x goes to positive infinity. As x approaches positive infinity, our f of x goes to 0. We can see that here. And as x approaches negative infinity, our f of x also approaches 0. So comparing that with this other one, you can see that the pictures are different, but how does that affect our characteristics? The domain is still negative infinity to 0, union with 0 to infinity. You can see that that's how wide it goes. But our range is a little different because this one doesn't exist in the negative region of y, so it is 0 to infinity. We do have a vertical asymptote at x equals 0, and we have a horizontal at y equals 0. Now what's mainly different here in these is x approaches 0 from the left, we go to infinity. Our function goes to infinity. And as x approaches 0 from the right, we also go to infinity. So these are going up, up. Then as x approaches positive infinity, so coming down here, we are approaching 0. And as x approaches negative infinity, here, our function is going to 0. Now looking at our asymptotes, how do we find them? For vertical, we're looking for where we're undefined, or where this denominator is 0. So we would just set the denominator equal to 0, and then we need to factor that. We're looking at x squared minus x minus 12. So those factors would be a negative 4, so that's minus 4, and a positive 3, that's 4c. Now remember, initially we borrowed that 6, so we have to return it. And then we have to reduce, so x minus 2/3 is 1 factor, and x plus 1/2. Now, typically you would slide the number over when you were finding the factors, but we're not looking for the factors, we're looking for the solutions, or the places where if we plugged in that number for x, we would get a 0. So those would give us our asymptote for this. So our asymptote for this one, we have 2 of them, x is equal to 2/3. That would make this 0. And then we also have the other one, x is equal to negative 1. So those are our 2 asymptotes. Now over here, I put a little note about holes. How do you know the difference between the vertical asymptote and a hole? Let's say we had a different one. Let's say we had 3x minus 2 over the problem that we just, the denominator we just did. Now notice something here. Let's split this over. That's 3x minus 2. And the denominator. So those would cancel out. Now, some people have the misconception that that means that 2/3 is not an asymptote. Well, that's true. It's not a vertical asymptote. It's a hole. It's still undefined there, so we can't have it. But instead of being an X, it is a hole. So that's how we know when we have a hole. Horizontal, we have 3 situations, and we'll look at all of them. So this is our first situation. We look at our degree of our numerator and our denominator, we compare them. So this is a degree 1, so 1 and 2, how do we compare that? 1 is less than 2. In that case, if our top degree is less than our bottom, our horizontal asymptote is at y equals 0. Obvious, and that's what that says. But what if our powers are equal? So we look here, those powers are the same, 2 equals 2. Well, then we have to find our horizontal asymptote by taking the coefficients and dividing them. In this case, it's 2, so y equals 2 is this horizontal asymptote. And then, that's this situation here. And then the third situation is when the power on the top is greater than the power on the bottom. In that case, we have no horizontal asymptote. So vertical, horizontal, and then we have slants. How do we know we're going to have a slant? Well, if you look here, it says if our numerator's degree is 1 greater than our denominator's degree. So this one right here, this example we just did, example 3, that would have a slant. So we have to figure that out. We're going to do with this. This one has a slant. How do I know that? Because the numerator is a power of 3, the denominator is a power of 2, and the numerator is 1 more than the denominator. Because 3 is 1 more than 2. So to find that asymptote, we need to divide 4x to the third plus x squared plus 0x is plus 3. And we're dividing that by x squared plus x plus 1. That was a plus, right? Nope, it's a minus. That should be right. So how many times does x squared go into 4x to the third? It goes in 4x times, so 4x, so that's 4x to the third minus 4x squared plus 4x. And I'm subtracting this whole thing. My cubes cancel. I have 5x squared and a negative 4x. I can bring down that plus 3. How many times does x squared go to 5x squared? Plus 5 times. It's 5x squared minus 5x plus 5. Tracking those. Those cancel. That's 1x minus 2. So that's my remainder. So this is plus 1x plus 2 over x squared minus x plus 1. Now, if you look at what I just wrote up here, it tells you how to find your slants. So you divide your polynomials. This right here, what we get, our quotient part, not the remainder, is our slant asymptote. So right here, our slant asymptote is y equals 4x plus 5. Remainder I'm not even worried about, that's just a remainder. It has nothing to do with my asymptote. Alright, so let's use these skills to sketch some graphs. So here's the rules for sketching a graph. Determine your domain, because that's going to help you. That's what we're going to do, our domain first. Now, if I can factor, I factor first. I might not need the factoring, but in case I do that. So that's going to help you with my domain. It's going to go from negative infinity to negative 2. Can't exist at 2. Then it goes from negative 2 to 2. And it goes from 2 to 2. Next thing is to find my intercepts. 2 sites. With my y-intercept, that's So I let x equal 0. So the f of 0 is equal to 0 over 0 squared minus 4, which is 0 over negative 4, which is 0. So that gives me a point right there. That's the point 0, 0. And I can do my x-intercepts. So for my x-intercepts, the whole function needs to equal 0. Solve that, and I can multiply by x squared minus 4 on both sides. Now what you're going to see is that when we do this with the rationals, our denominator is going to be 0, or it's going to multiply out. So x equals 0 in this case. It doesn't always equal 0. So that's the same. Now we have to look at wholes. Well, wholes happen if I have something in the denominator cancel with something in the numerator. That didn't happen. So wholes, I don't have any. Then I need to look at my asymptotes. So start with vertical. Well, I'm going to have to. Wherever these equal 0, my denominator, so that's going to be x equals a negative 2, and then x equals 2. I like to go through and put some lines in here. Horizontal. So my top is 1, my bottom power is 2. 1 is less than 2, so there are none. My bad, that's wrong. Bottom is less, there is 1. It's at y equals 0. It's the opposite of this. Top is greater. So it is at y equals 0. Goes through right here. Now keep in mind with horizontal, you can go through those. It's not like the vertical ones where your graph can't go through it. Then slant, would there be slant? That's what I started thinking, oh, I made a mistake. Slant is when my top's bigger than my bottom by 1, and we do not have any slant here. No. So then that's probably not enough graph. So I need to plug in some other points. I can plug in 1 to get a general feel of what that's going to look like. And that's 1 over negative 3, or negative 1/3. So that's going to be right about there. I can plug in a negative 1. I plug in a negative 1, I get a negative 1 over negative 3, so it's going to be a positive right there. So it's going to be right there. So it's giving me a general idea of what it's going to look like on this side. And then I would do the same on the other side. I would look at when I plugged in a 4, what would I get? That's going to be F4 would be 4 over 16 minus 4, which is 12, which is 1/3. And I can see this is going to be swooping down. And then I could swoop it the other way by checking 3 and see where that goes. And the same thing on this side. You would do F of negative 4, which in that case you would get a negative 1/3. Alright, let's take the last one. Step number 1 is to find my domain. I don't need to factor the denominator here, but I do need to factor the numerator, so I'm going to do that first. X minus 4, x plus 1, and then my denominator is just x plus 2. That's just in case I need it. So my domain, everything except for negative 2. So negative infinity to negative 2. Union with negative 2 to infinity. Once I do that, I need to find my intercepts. So my y-intercept is where f is equal to 0. 0 squared minus 3 times 0, so for nothing, minus 4 over 0 plus 2. Negative 4 over 2, which brings the point negative 2, and that's 0, negative 2. That gives me 1 point. Then if I do my x-intercept, that's sending the whole thing. I'm going to do it as factored, because I know I'm going to need that. And the whole thing equals 0, when I multiply by x plus 2 on both sides, so you get it out of the denominator, cancels here, that stays 0. Then looking for x minus 4, x plus 1 equals 0, and that's 2 places, 4 and negative 1. So that gives me 2 more points, 4, 0, negative 1, 0. Right there. Now holes. Well, there's nothing that's going to cancel here. I can see that up here. Nothing's going to cancel, so that's no holes. Now I start looking at my asymptotes. So vertical one. Of one spot where x is equal to negative 2. So remember, it's where my denominator equals 0. Let that equals 0, so that's at negative 2. So that's my vertical. Now, looking at horizontal, what's my power? On top I have 2, so horizontal. Okay, my power is 2. And then my bottom is 1, 2 is greater than 1, so that is none. The top is greater. But I notice right away that the top is greater by 1, so I'm going to have a slant, which means I have to divide. So, because I'm dividing by linear, I can actually do synthetic here. 1, negative 3, 1, negative 3, negative 4. Dividing that by my denominator, which is a negative 2. Bring that down. Negative 2 times that is negative 2. That is going to be negative 5, 10, negative 6. I don't really care about the remainder. Remember, that's not important. This is important. This is telling me that my slant has the equation y equals 1x minus 5. So sketch that in there, starting at 5 and go up 1, up 1, up 1. There is my slant. Now, I could plot some more points. I can see right here what it's going to be, right here, like that. And then I could plot some points down here to get those. And there you go, it's all finished.